Hello and welcome to this another week of our online lectures on multimedia. And this week we'll be talking on something augmented reality and virtual reality. So you know that uh, our technological progress and even the investment from the capital market, and corporate worlds, they are basically heading towards this technology, something called augmented reality and virtual reality. Perhaps you have heard of some of these things, and maybe you are knowingly or unknowingly basically using these stuffs in some scale. So and these stuffs are very much related to multimedia, and most of the contents are basically multimedia and multimedia related. Definitely this is a very interdisciplinary subject. So there are a lot of things from computer science and control engineering, electrical engineering, but I believe that with it context of our multimedia course, discussion some part is good. So that's why I chose this topic and I included in the syllabus. So let's see. So we'll be trying to have some idea on what are the applications of augmented reality, and is what are the technologies, and the same things for VR, what are the applications and what are the technologies. And definitely some related things will be coming out, and the detailed contents that I'll be updating after I finish this PPT presentations preparation. Now before we start, let's say something that these lectures that I am preparing, AR and VR, basically they are very related concept and related concepts, and sometimes are they are mixing together, so that's why it is not a good idea that we just study AR very separately, VR very separately. It's not that. Especially in the beginning, for conceptual purposes, we need to mix up. We will refer VR when we describe AR, when we will refer AR when we describe VR. So that's the idea. Okay, so let's see what is augmented reality. So augmented reality is basically, this is a way that how we look into our real world. Okay, so for examples, we can see our real world that we can look directly, or we can look via a devices, for examples a mobile phone camera, right? So that means if we just place our, for examples like this one, see that here what we are doing is we have a camera in this tab, right? Or let's say these devices. So we are placing this, we are pointing this camera toward this physical world, and then we are getting the picture over here, right, on the screen. Now say that, let's say what we can do, the very first things we can do, we can zoom in, right? So zoom in, zoom out, that kind of stuff we can do. So that is definitely some sort of augmentation, that we take a picture and then we just zoom in and enlarge the view, and maybe we can find something. That's definitely, yeah, some sort of augmentation. Augmentation means increasing of the reality. Okay, but in here we mean AR is basically, okay, as we are we are taking the picture, that's fine, but in addition we will impose some additional computer generated information, or some we can say some other information we will overlay on this information. So that's some sort of we say that's augmented reality. Now this additional information that we will overlay, that that is basically the computer generated input, that's going to be simply graphics, or simply audio, or might be video, or whatever it is. So the strict definition of AR is basically the computer generated content in AR is an overlay on top of the real world content, right? So you see this is basically a Pokemon Go game is basically an AR game, maybe 2016 17 around this game. And actually this is at my office. I mean, if you're curious, I mean, if some of you don't know, this is at my office, and I was actually placing this in Android. I installed this Pokemon Go, and then when I just point my camera on these sides, you see, then this Pokemon this Pokemon over here, this came, right? So these are my physical world, but this I mean, when I'm pointing into these directions, so let's say it assume that, okay, I'll have to find and search that which directions this kind of, Pokemon, comes in. So when I place in that direction, this comes in. So it means I found, something, right? And here, when I was pointing in other times, it see there are some forest and comes in. These are my physical world, but this is, something, some forest or some jungles, plants comes in, and I'll have to find the Pokemon inside of that things. But because, I was doing these things in some, my office environment, that's why it's look like this. But if you go to the real, park, or something where there are some green plants or something, you really find very exciting these things. Even you can install it and you can see how it looks like. And if you already know and familiar about it, so you know that what I'm meaning, okay? And what is the virtual reality? Virtual reality is basically is different from augmented reality in a sense that virtual reality creates a completely, a simulated environment that basically doesn't exist physically. So that is your completely, own from computer program or something. Or maybe, we might have some images. For example, let's say, to create an artificial environment, what we might do, maybe, we go some top of the mountain and we take an image and we use that image to create that environment. That's okay. But currently, when we are, looking and we are immersed in a some sort of virtual environment, so that is basically completely, disconnected from the physical reality. Okay, so that's why we were saying this virtual reality is basically an immersing computer simulated reality that creates a physical environment that doesn't exist. Okay, so for example, so this is one example of a VR environment. See, so, and what do you think? This is basically, you see, these are, a coral reef, right? Coral reef. If you really go, underwater in the seaside, you will be amazed by looking what are the beautiful, things are those. So these blue basically a digital media franchise company. They, come up with some virtual reality based interactive simulation of underwater environments that if you just, go and look at this environment, then you will see, this is basically VR based. Okay, definitely you need some instrument, and then you can interact, you can go and here you can explore, and you can, touch them and those kind of things, right? So that's called virtual reality. So you basically immersed yourself into a virtual environment, and then you do a lot of stuff there, right? You somehow you are familiar with. So this is one example. And interestingly, you see, while you just go through here, you see they have, even you might encounter is simply a whale, so that's exciting, right? Okay, so this ARVR basically, it's long back it's came, this kind of concepts, but so recently, it become, booming and about a very emerging market. The reason is, because of the smartphone. In today's smartphone, we have, camera, accelerometer, gyroscope, right? Or gyroscope, anyway. So these are, camera, accelerometer, and gyroscopes. These are basically your motion tracking, right? And then also you have magnetometer, GPH. This basically enables the location, to identify the location. So location, motion, and this kind of things you most of the things needed, for making this AR VR, softwares, applications, and products, right? So that's why, we say that many of the components that the smartphone has, for example, these gyroscopes, cameras, accelerometers, and others, miniaturized display devices, those are basically the essential parts of AR VR headsets. And because the demand for a smartphone are huge, so that's why mass productions of this component become easier. Now, the little history on and some side notes on AR and VR, in the human history, some people say that the first, portray of this immersive reality, comes through a head-mounted display. Okay, something called head-mounted display like this. You see, and this was created by Ivan Sutherland in 1968. But you see, this is very massive, and it was very big and bulk, and it was not possible to produce in for consumer level. But it was for experimental level, it was okay. But that was the starting, right? But interestingly, at the time, the name he coined maybe something, sort of Democles or something. But then the real terms actually came in augmented reality. This term was coined by, Boeing researchers, the Boeing Biman company, the flight company. So their researchers, when, they were doing some sort of, training for the pilot, for example, these, for landing, crashing, and various kind of things, real crashing, real landing, this is difficult, right? So for their purposes of different kinds of training, so they actually first invented this kind of terminal, augmented reality for their own purposes. But definitely that later on evolved to something different. But whatever it is, this is again the history. So you see, a standalone headset, if you have VR headset or AR headset, that doesn't require external processor, memory, or power. But sometimes if you are not standalone, then you need some external something, for example, mobile set or your PC, computers, those kind of things. Okay, so definitely the combinations of their hardware and softwares, many smartphones can view AR experiences that basically are less immersive than this head-mounted display. So that we'll have to understand this. So that means we need some sort of head-mounted display for fully great experiences. This is AR evolution, but this is not really AR evolution, but I'm just giving an example in terms of Google. Perhaps you have heard of the name of Google Glass. This is basically very small wearable computers, and that's basically hand-free work. So when you look at some places, and that it gives you the related information. So that was not exactly AR product, but we can somehow think about that. Then later on, they came up with something called Tango, or sometimes we say Project Tango, because it was in testing phase. So this is was in true sense, it was an AR computing platforms. And this Tango project or Project Tango, basically they included some this was a smartphone, but they basically included some special motion tracking camera and depth sensing camera and some sensors, and also they had some powerful computer vision processors, right? So so these are some specialized hardware, and then they built some specialized software to operate to utilize this hardware for the augmented reality functions. And then that evolved into something called AR Core. Now, AR Core basically now in today's very powerful software development kit developed by Google, and that allows that you can develop any AR applications. So if you like to build AR applications, you can use AR Core, and then you can come up with fantastic software and applications. And I hope that some of you are will be working on this AR Core, or maybe some AR software development, VR software development, because it has a huge market. You can learn from now. You can spend 6 months to learn, and then you can actually can work in various companies. So we talked something called augmented reality, that is called AR, and then we saw something called VR, that is virtual reality. But some other related terminology that's also very much important to know. So one of the such things is mixed reality. Mixed reality is basically, as you know from the name, it basically integrate between the real world and the virtual world. So then interact. So that means it may sometimes can function as a VR, sometimes function as a AR, right? So for example, think about, let's say, AR based mixed reality. So what you can do, you created some digital content, right, that you are interested to overlay with your physical world. That means you just, let's say, hold on your phone in front of some physical environment, and then you look at the environment, and you create some maybe digital content depending on the applications, and then you overlay on that. But let's say you also allow some interactions between this digital content and the physical world. So it would be so exciting and cool, isn't it? For example, see that you are basically in your room. So in your room, so you have some walls and floors. But how about then you just create a digital soccer ball, and this digital soccer ball may be bouncing off the walls and floor So it's very cool and exciting. So it seems that you are basically playing, or maybe some ball is basically bouncing back, in front of your walls and floor. So that kind of things. So this is, we say, AR based mixed reality. So mostly why we are saying that, AR based mixed reality, because mostly your content is physical, then you have just a small digital content, and that digital content interactive with that physical environment in your created environment. That's the things. So see, this one is basically in another example of this kind of things. This is Microsoft HoloLens. This HoloLens, basically this is a headset. It has an ability to scan the physical environment, then it mix up the digital objects. Okay, and then maybe user hands can interact with those digital objects. If they are physically there. So that means you have some, this is some physical environment, maybe your office or somewhere, and then you wear this one, right? And you can see this physical environment, and maybe it creates some digital object like this, and this digital object is basically interacting with this physical world. So that's the idea. Again, it is similar to AR object, mixed reality. Then we have called augmented virtuality. See, augmented virtuality, we are not saying augmented reality. So in augmented reality, reality was augmented, but in augmented virtuality is basically opposite of augmented reality. So that means this AV, augmented virtuality, is basically mostly digital content, but you basically also give some interactions of the physical content. Think about like that. For example, you are extracting some video from the physical environment, and then you are placing this physical that streaming video into a virtual space, that you created some 3D digital representations. So that kind of things of physical object. You have a physical object, maybe you have created some digital version of it. So this is mostly digital, and then you are mixing up some real world video. So that's the idea, that what we mean. So it seems that the video is basically real video streaming, and the content is your completely virtual. So it seems the mixing and interactions between this physical and that's reality, right? But predominantly, mostly the content is virtual. So that's why we are saying augmented virtuality. So, and then there is a term called extended reality. Extended reality is basically the umbrella term that includes everything that we talked so far: virtual reality, augmented reality, augmented virtuality. So all of these things, we say under the terms extended reality. And this, by the way, this extended reality is basically one of the core concepts, or we say truly immersive reality that, sixth generation, 6Z. Now we are in the age of 5Z. Now when 6Z will be coming, this true extended reality, or we say truly immersive reality, immersive. Why we say immersive? Immersive means you create an environment, a digital environment, virtual environment, and then you yourself immersed, you yourself move into that environment. So that's called immersion, right? You basically immerse yourself into that environment. So what I told, that in 6Z, this immersive reality or extended reality will be a one of the core concept. So when comes this various kinds of terminology, so we can think of like this kind of scale. This is scale basically proposed by Paul Milgram's reality scale. This is more appropriate, we say virtuality continuum. Okay, so this is a scale in a sense. Let's say we have a line, and real line or whatever it is. Let's say left side is basically represent a real environment, and if as you go to the right side, you are moving toward more virtual environment. So that means this is, as you go to the left side more and more, it is basically real, more real. As you go more, it's virtual. So now augmented reality basically relies, let's say this is the center point somehow, and let's say augmented reality is basically somewhere here. That means mostly your environment is physical, and you are just mixing up some digital content. So that's what augmented reality. And virtual reality is at the right side, and augmented virtuality is maybe somewhere here. So you are saying that, okay, mostly all my content is virtual, but I am taking some content from the physical, so physical world. So that's why it is that one. And when you mix up this augmented reality and something called this virtual reality, virtual environment. You mix up these things, then you become basically mixed reality. So that's the continuum that you need to think of. And all the terms, we can say this is basically extended reality. Now, what are the applications? Applications are enormous amount of applications. I just list down here some of the things here. Maybe you might know even better applications, but some of the applications, so for example, let's say first see augmented reality applications. For example, shopping and retail. Yeah. So while you are shopping, maybe these are some you can see various. Maybe you saw Amazon, or maybe AliExpress, or maybe coupon. That when you click some item, you can basically zoom in on those. Those is some very little things, but a very a very good and unique applications is like that. For example, ICA, right? Furniture shop, you go or somewhere that you don't know that how this furniture fit in your room. So what you can do, you can actually fit that you have your room, and then you just take this furniture in your room. So you take a camera from your photo, right? That you take a pictures of your room, and then you fit this furniture. So that is a 3D shape of your furniture basically placed on your that room, and then you can look that how it feels. It not just two-dimensional images, basically looks like a 3D shape that you can basically see. So your environment is mostly physical, then you are just taking those content and trying to see that it fits or not. So that's kind of things. So this market is huge. And think about that, some warehouse, warehouse sometimes is very messy and very big, and some new worker, they are struggling where to go, how to go, so what are the instructions that are coming from my managers, so that kind of things. So that kind of warehouse navigations can be done by augmented reality. Also, for example, let's say your architectures go and then try to see that if it is this kind of architecture fits in this environment, how it looks like. Maybe it goes here and then see that, okay, if I make a sketch of the building in this, how it looks like. So this is just an example. Other example he gave that gaming, we can use it, right? So this shopping and retail, this kinds of various kind of professional works, and like gaming, that is entertainment. And also this social media is a big consumer of augmented reality. Think about like Snapchat filter, right? This kind of filter just came so maybe around 2016 or 15. Snapchat first came up with, and that was a brilliant idea. So at the time, even we didn't know that's called augmented reality. So, but the concept is augmented reality. And you see the Facebook Spark AR, right? You can create a spark in Facebook if you use this AR kind of stuffs. You see maybe some this is your photo, but then some kind of manipulations comes in, kind of glowing, shining, and maybe some other kind of bizarre or very strange things you can do. And how about Google 3D sticker? So to do more realistic chat and more engaging, Google comes up with the concepts of 3D sticker. So that's also AR applications. Other applications maybe is a very huge, and I'm a big fan of that, the classroom educations. So you see that classrooms education is going on, and then you have this kind of terminal. So when explaining something, this can be augmented here. So that is the classroom educations. So for example, medical education, there are very complex organs, and various kinds of explanations need. So medical students and teachers, they can go through and augment those kind of stuffs. Even actually we also sometimes use it, right? That how we are using. And these very related things in the medicinal is very sophisticated training, not only in medical field, any other fields, very sophisticated training we can do, like pilot training. And that's the example actually also in AR, right? Augmented reality. So and even that there are some AR books, augmented reality books. So that means you go and buy the book, and then you have an app you just place on, then you just place that your phone on this page, and then this 3D forms comes in, and you can see that. So for the training purposes it can use. Even it can be highly useful for this kind of real time surgery assistance, right? So surgery is going on, then it can take the pictures, and then you can augment this scene, and then they can perform the surgery. So even remote surgery is possible. At least the other people, they can learn from the remote surgery. You know that when some very sensitive surgery comes in, and that kind of sensitive surgery is basically not common. So for example, let's say in USA there are some sensitive surgery, but from Korea, the doctors and physicians, or maybe from India or maybe some other country, the doctors, they can remotely see that kind of how they do the surgery, and that kind of augmented reality can work, and they can learn as a training purposes, right? The VR applications also very related. Some applications are basically mixing, but one application says in medical stuffs, even this VR is mostly for entertainment things, but it turns out that we can utilize for various other purposes. For example, mental health. Sometimes the nurse, doctor, or physicians, they can basically interact with the patient through this VR, and when these patients basically navigate through various kinds of environment that he likes and wants, so physically and mentally he feels relaxed, right? So there's kinds of mental treatments actually become useful, and many research done, and they show that the VR become useful to treat these mental patients. And as I told you that VR is also highly useful medical training. For example, so let's say you will do the surgery, right? And even let's say this is physically doesn't exist, right? But this you can take a training that as if this is a real patient, right? You can actually do stretching, and you can take out this something called your stomach, heart, and those kind of things. So and then it can be recorded, and then maybe other teachers or professors or maybe some professional, they can see that you really did correct or wrong, right? And then you can again reiterate. Once you learn something, then when you do perfectly in this simulation environment, then actually you can now go to the physically. So it's much more interesting. The VR also can be useful in military training because it's as the same as the Boeing pilot training. Also recently, it turns out that it can also be used in a fashion industry for your virtual catalog, for rehearsal, various kinds of promo. So there are lots of things, and especially this fashion industry turned out into virtual stuffs, virtual reality, because of this COVID pandemic. So there are lots of technologies involved, as you can imagine. It's not really very simple thing, but ultimately you will be just working in a very tiny area. So depending on your expertise, your interest and experiences, or maybe your opportunity, maybe you will be working a very tiny escape of that. So you see the roughly this tree divided into four 5 branches. For example, this is one near eye display, and this is basically content creation, and then network communications, rendering, processing, and then we have something called perception and interaction, right? When you see the near eye display, as you can imagine that we are just dealing with our vision and eye. So display is huge matter, and especially the very first thing that what kind of optics and optical properties we'll be dealing with, right? Multifocal display, or maybe this kind of jumbo display, this light field display, optical waveguide. There are various kinds of features that we need to work with. And also, for example, so what kind of display? For example, it might be micro LED, or might be OLED, or maybe AMOLED screen. So those are all will be studied under near eye display hood. And then we have content creation. Content creation is definitely the normal content, audio, video, and image is really different from this when we will create something for augmented reality or virtual reality. So this is basically the technology is used for both. So for examples, for gaming and social things, you need different contents, right? So first you need recording, that how you do the editing and corrections, preview, and then you will design the content based on your applications area, right? And then when comes the communication, there are a lot of stops, and here definitely you need very sophisticated networks and very high precision networks, or maybe tactile internet, 5G and even 6G. You need that kind of networks. So we are not talking on that now. Then rendering processing is one of the very big things. You know what is rendering? Basically, many of these rendering things we basically studied, that when you look at the finally on your screen, let's say 3-minute video, 4-minute video, when coming in front of you one by one, basically what each pixel color is, what is the color of the next pixel, what is the color of the next pixel, what was the actual color, what was the actual pixels, so what is the frame, and what are the environment, how the lighter interactions, those all of these things play together, and then based on that you basically produce like some sort of a final image. So that's called from a series of frames and pixels you are coming up with a synthetic image onto your screen. So that's the rendering process goes on. So this is basically a very computation and math, color model, those things behind. And actually we studied those things, and when you need it you can use it. I'm just contextualizing that when you need it. And then definitely you have some other kinds of from the tracking, computer visions. Those are final other output things you need to do. For example, you need different kinds of control situation tracking, voice interactions, brainwave, and hand interactions, right? You are playing with the hand in virtual reality. You maybe you are need to eye tracking, so that kind of things, right? So those are some technologies. Now, let's say, what are the status, recent status? Even though it's a recent status, but I took it from a book. That book is even came maybe 2018 book. But by this time, maybe second generation, third generation, fourth generation came. Maybe second generation comes in. But it is just a reference purposes. It is good. So if we see that, for example, let's say virtual reality recent status, most VR hardware is like that. For example, you have HTC Vive, Oculus Rift, Windows Mixed Reality, then PlayStation's VR. And if you see different kinds of comparison, you can see, but mostly you have to see that what are the platforms. For example, HTC Vive, it works on Windows or Mac. But this Windows Mixed Reality, look, this Windows Mixed Reality is basically some specification. Okay, it's not just like HTC Vive or Oculus Rift. Windows Mixed Reality is basically a guideline by Microsoft. So they don't come up with their own VR set, even though there are something. But here we mean this is a recommendations guideline. And if some another vendor they produce some VR headset following these Windows Mixed Reality recommendations, then that we say Windows Mixed Reality 1. But this Oculus Rift, HTC Vive, this is basically coming from HTC, this is coming from Oculus Rift, right? And this is PlayStation's VR, right? So and also you notice these three, HTC Vive, Oculus Rift, Windows, they basically all works on Windows or Mac platforms. But this PlayStation's VR, is coming from Sony. They have their own platforms that comes up with, their own this headset itself. So that means for that you don't need to install some software like on your PC like Windows and those, but you need some sort of gaming console for that. And experiences, you may be different, and what are the how much field you can cover, 110 degree or maybe some 100 degrees, and resolution per eye, what is the resolution, what is the headset weight, refresh rate, controllers. So the various kinds of these components things are there. So these are some comparisons, some spec we can say. And this space basically we are saying for the desktop headset comparison for virtual reality. But definitely these are for to use this one, you basically need to install some software for this HTC Vive, right, on your desktop. So that's why we are saying desktop headset comparison. And then you definitely have then mobile headset comparison. For example, Samsung Gear, Google Daydream, Google Cardboard. So these are basically you need some platforms is Android. You need those kind of your smartphone or those kind of things, right? So this is basically we are saying mobile headset comparison. And again, these are the similar comparison we are doing. Now let's say some features. Let's say VR features. We saw something like these kind of things that for example. Your experience is stationary room scale. Let's explain this terminology. So room scale experiences, we say in VR features, one is room scale experiences. What does it mean? It means that when you are taking a VR headset and you are a user, so you can freely walk around your room. Okay, so you just first initially when you set up, you basically give the instruction, okay, this much of space that I have, and then I will be moving around this space. So that kind of things you can set up to create when you will be moving in your digital environment after taking the VR headset, so it automatically track you and keep you within that space. So that means you have an ability to move around your room. So that's is room scale experiences. And some other VR set, basically they are stationary experiences. You are not allowed to move, just you are standing or seated, and little bit maybe you can have little move, but that's not actually movement. The real movement, the freely move, you can do this within this one, but still this space is limited. And when this VR features comes in, you often hear something called outside in tracking or inside out tracking. There are two modes of tracking. Okay, now outside in tracking is, for example, this is called outside in tracking. So here what we do is we have, let's say, headset, and this is the headset, and we are in the room, but then I will be moving around this room, right? But when we'll be moving around this room, so we need some how we understand how this VR set will guide me. So for that we need to have some additional sensor or camera. Let's say I fix this camera in the room from here, maybe in 2 or 3 different locations, or maybe at least 1 locations, and then this location is specific. So in reference with this location, this headset will then be commanded, okay, I'm now here, that kind of things. So this is called outside in. So that means it was outside that I'm taking inside my room. This is called outside in. Okay, and now there is another called inside out tracking. Inside out tracking means that I'll be taking the inside out. So that means I'll be taking the camera that's basically attached to the headset, so I don't need to place some extra additional things there. So that's called inside out. So that means within the headset there will be some camera and sensor especially designed that will be tracking that I'll and detect my space and room. So then some other features is haptic feedback. So haptic feedback is for example sense of touch, designed to provide information to end user. For example, when I'm touching something or I'm just picking up some item, you look and think about that. You are basically in a very you are with the VR headset and you don't know many things, right? So you need to understand that what I'm closing the door, or I'm opening the door, I'm pressing a button or not. So that kind of information basically you can get if you have this kind of haptic gloves, right? Haptic gloves can touch, and that's called haptic feedback. So so that's the idea. Then you have the other features is 3D audio. Human, when you listen some voice or something, basically we can perceive is 3-dimensionally. So we can distinguish that the directions from where the sound is coming. So that kind of feelings we need to have when we are in a VR environment. So that's called 3D audio. And definitely you also need to supply some special audio. Now depending on your VR company and VR set, maybe sometimes you have 3D audio, sometimes special audio, but special audio is very much common. So it basically you see that the placement of user ears, that basically opposite side of the head, right? And then it adjusts the sound appropriately. So if your sound coming from the right side, then your left ear getting the sound little bit in a lately, and the vice versa. So all of those kind of things need to be adjusted. And if you have this spatial audio, spatial, it may be coming from the space, that's called spatial. Then you have different kinds of controllers. So we say VR controllers. So one very common controller is integrated hardware touchpad. For example, this Samsung Gear. So in Samsung's this integrated touchpad, so this means this is called touchpad. This is basically we can use for tapping and maybe clicking and swipes, that kind of things. Also you have something called home button and some back button, that kind of things. Also, there are some control like guest controller. Guest controller means eye tracking, right? Eye tracking is really very interesting, and the more eye tracking stuffs will be coming. And recently we published a research paper based on robot eye control and eye guest control, that kind of things. So we need to be able to track our gaze, that when I'm looking at something, how much I'm looking and at what angle I'm looking at. That's kind of things we need to control. And then sometimes you have some these game pads. Gamepad is also very very interesting. Many headset and controllers, they support this standard gamepad, because the gamers are already familiar with this kind of solution, so they know how to control this, how to use this. So many headset, they supply this kind of gamepad. This is basically Xbox One controller. Then you need motion controller. For examples, think about that. When how is the user hand situation. So my hand, where is the position of my hand, and what is the orientation, and what are the motion of my hand. So that's very important, because your hand, maybe you are going something, or maybe you are fighting with something virtually. So your hand is moving. So what is the position and orientation and motion of your hand? This is very important. So this motion controller, that's why an integral element in VR, as in VR controller. For example, this is basically your motion controller. So if you have these things in your hand and then you move, you see there are very small just light sensors kind of. So basically when you move, so these are moving, right? So these are moving, and then your headset it can control that, okay, where is this position, where is that position, where is this position, and then accordingly it can sense the position, orientation, and motion of the user hands, right? So that interactions become more realistic. And then you also have hand tracking. So hand tracking is basically is the same work as motion controller, but in this case you don't need to use any kinds of motion extra or additional hardware. So you can basically when you install and when you set up your VR headset, you basically in the starting you basically show your hand and finger, that it creates your some digital hand inside, and then you can train your headset that, okay, this is my victory sign, this is that, this is this, and then your digital hand copy these things. So that's the idea of hand tracking. So okay, so let's move to the next part. We'll be talking something in AR functionalities and various other related things.